Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12, Build Your Understanding, question number 1. Question is, a charged particle A is fixed at the base of a uniform slope of inclination alpha. Another charged particle B is placed on the slope at an angular position beta from the line of greatest slope through the position of the first particle. And the slope is mu, which is less than tan alpha. For the particle at B to stay in equilibrium, what could be the maximum value of the angle beta? Let us solve this question. Charged particle at A is fixed. Another charged particle is kept at B. This angle, as per question, is beta. Mu is the coefficient of friction between the particle B and the slope surface. So which all forces will be acting on particle B? One will be the electrostatic force of repulsion along this line between A and B. One force will be mg, that is vertically downward, and the component of this will be along the slope will be mg sine alpha, we know. Third force will be ff, that force of friction. Force of friction, the direction of force of friction will be opposite to the resultant force, that is Fe and mg sine alpha. On the slope, it is said that the particle B is in equilibrium. For that to happen, all the forces acting on particle B on the slope, the vector sum of all those forces will be 0. So if we take this direction as y-axis and this is as x-axis, so summation of force along the x-axis, summation of force along the y-axis should be 0 for the equilibrium. This diagram has been made for convenience to understand. This is Fe, that is electrostatic force. Beta is this angle. Friction force is acting along this. We have said that theta is the angle that friction force is making with the x-axis. Mg sine alpha is in this direction. N is this is normal reaction force N, and it is perpendicular to this and perpendicular to the slope, and we know that this will be equal to the component of mg along the perpendicular to the slope. So that will be mg cos alpha. So n is equal to mg cos alpha. In the slope problem, we have done it many times. You must be knowing it. Now we have just flipped this x and y plane like this to understand or visualize in a better way. So mg sine alpha, as we have seen that it is acting negative of the y-axis, means towards the negative of the y-axis. So this direction we have shown it here. Fe is making an angle beta with the y-axis. So this we have shown here. Friction force is making theta angle from the x-axis. So that has been shown here. Okay. Now we will write summation of fx is equal to 0. Put the value. Electrostatic force, the component of electrostatic force along the x-axis is Fe sine beta, because this is beta, so this is 90 minus beta, so this Fe will be Fe sine beta, and component of friction force in the x direction is Ff cos theta. So this is equal to 0. Ff we can write mu into n, normal reaction force, so there is no motion along the perpendicular of the slope. So n will be equal to mg cos alpha. So we can write Ff as mu into n, that is mu into mg cos alpha, and the component of that in the x direction cos theta. So this is equal to 0. So we will be getting this equation. Fe sine beta is equal to mu mg cos alpha into cos theta. This is equation 1. Now we will use summation of all the forces in the y direction and equate it to 0. So in the y direction, a component of electrostatic force will be Fe cos beta. Friction force will be Ff sine theta, and Ff we know that it is mu mg cos alpha, so we can write this minus my mg sine alpha, and this will be equal to 0. From here we will be getting equation number 2, Fe cos beta is equal to mg sine alpha minus mu mg cos alpha into sine theta. We will divide equation 2 by 1. So we will get cot beta, and upon simplifying we will be getting equation 3, that is tan alpha into sec theta minus mu tan theta divided by mu. For beta to be maximum, we will differentiate this equation with respect to beta and see at what theta it should be 0 from maxima and minima. So we have done that. Upon solving, we have got two value of theta. Sec theta is equal to 0 and sin theta is equal to mu cot alpha. But sec theta is never 0, as we know. So this solution is discarded. The only solution we have is sin theta is equal to mu cot alpha. We have shown it here for simplification in right angle triangle, that this angle is theta. We know that sin theta is equal to perpendicular by hypotenuse. So this is perpendicular, mu cot alpha. Hypotenuse is 1, because mu cot alpha divided by 1 will be mu cot alpha. So hypotenuse is 1. So base will be h square. H square is hypotenuse square minus b minus p square. And whole thing in under root. So this will be 1 minus mu square quarter square alpha. Now we will put the value of sec theta and tan theta in equation 3 to check cot beta. Upon solving, we will be getting this square root of 1 minus mu square cot square alpha divided by mu cot alpha. Answer has been given in sine inverse form. So we will have to write the equation for sine beta. So sine beta from this triangle, right angle triangle, is P by H. So mu cot alpha divided by 1. So beta will be sine inverse cot alpha. So this will be your answer for this maximum value of beta. The particle at B will be in equilibrium. In case of any doubt where you have not understand, please write in the comment box. I will clarify. Thank you.